So we have a function g of x. It doesn't tell us what these two elements are. It says they're real numbers, so therefore this is a real polynomial. Alpha, beta, gamma are the three roots of the equation, where it's a cube, so we should have three roots. When g of x equals 0, where alpha, beta, gamma are in a set of real numbers, so alpha, beta, gamma are all real numbers. Write down the value of alpha, beta, that's sum and product of roots. So a sum of roots is negative a n subtract 1 over a n, which in this case there's a n subtract 1 is negative 7, so it's negative 7 over a is 2, which equals 7 over 2. That is therefore alpha plus beta plus gamma. Part B. Okay, so what's the new information? A function h of z. So now this could be complex roots. H of z equals this, where RST are real numbers. RST are real, so all the coefficients are real. It's a real polynomial. Alpha, beta, gamma are also roots. So actually, alpha, beta, gamma are 3 roots, but we're expecting 5 roots. There must be 2 more. It's given this is, so z is one value p plus 3i. It's a real polynomial, so p plus 3i is a root. Therefore, p subtract 3i is a root. Sum of roots should be, I want the negative of that, so it's negative 11 over 2, which equals 11 over 2. And we know that alpha plus beta plus gamma plus p plus 3i plus p subtract 3i, so the sum of the roots must be 11 over 2. Substitute, because we know that alpha plus beta gamma come to 7 over 2. So we get 7 over 2 for alpha plus beta plus gamma. P plus p is 2p, and this subtract this is nothing. So plus 2p equals 11 over 2. Subtract 7 over 2 from both sides. 2p equals 4 over 2, which equals 2. P equals 1. So we found, show that p equals 1. That was good, then we've done that bit. It's now given that h of a half equals 0. That means that alpha and beta are in positive integers. Alpha is less than beta, and gamma is a set of rational numbers. Well, that must be a root. So, as you can't see, it just says find the value of the product AB. So we know that gamma equals a half. We can use, we can't use the first equation. We can do the product of roots here. So product of roots because we want alpha beta, it's assumed it's a product, so product of roots. So alpha beta gamma p plus 3i p subtract 3i is equal to product of roots. It's a power 5, so we make this a negative, so that's 20 over 2. So that's negative 20 over 2, which equals 10. But we already found that p equals 1, so we get alpha beta times a half. And this is 1 plus 3i times 1 subtract 3i, which is 1 squared plus 3i subtract 3i subtract 9i squared. So that is that's 1 plus 9 is 10 equals 10. That means that alpha beta equals 10 over 5, which is 2. So let's look if alpha beta is 2. They both have to be positive integers, so actually 1 times 2 is any way of doing it. So this must be, alpha must be 1 and beta must be 2. So that means that alpha equals 1, beta equals 2. We can check that. Should have alpha plus beta plus gamma should equal 1 plus 2 plus a half, which equals 3.5, which is 7/2. So that's our check, which is correct.